Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Continuous delivery lets you get new features in front of your users as fast as possible without introducing bugs or breaking production, and GoCD is the open source platform made by the people at ThoughtWorks who wrote the book about it. Go to dataengineeringpodcast.com/GoCD to download and launch it today. Enterprise add-ons and professional support are available for added peace of mind. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host is Tobias Macy, and today I'm interviewing Ewen Cheslack-Postava about the Confluent Schema Registry. So, Ewen, could you please start by introducing yourself?
Sure. I'm Ewen Cheslack-Postava. I'm a software engineer at Confluent, where we're building a streaming platform with Apache Kafka at its core. And part of that was, and continues to be, working on the Schema Registry.
And how did you first get involved in the area of data engineering and data management?
Sure. So actually, in a sense, I've never done data sort of engineering and management myself. I actually sort of got into it, distributed systems via a sort of unusual path. I started out in graphics in academia, so I actually have an academic background. And in graphics, I ended up on a project working on large-scale virtual worlds, which took me into distributed systems. And then ended up moving into, from distributed systems, sort of found Kafka, found Confluent 3 years ago, and saw a lot of interesting distributed systems problems to solve. And obviously, with a storage system like Kafka, a lot of those are going to revolve around sort of data engineering and management.
And when you're talking about large-scale virtual worlds, are you talking about things like Second Life and EVE Online and that kind of variety of virtual world?
Yeah, exactly. So it could vary between sort of the more social ones, which is things like Second Life, or more like games like EVE Online. Yeah, and my research was basically targeted at how to visualize such large-scale worlds more effectively.
And what sort of focus for visualization was that? Is it in terms of the network traffic between servers or the ways that the data is distributed geographically, or is it sort of a time series visualization of interaction patterns? I'm just curious.
Yeah, sure. So this is actually, it's mostly about the rendering aspect, but that, as you mentioned, sort of comes or has a variety of problems associated with it. The sort of fundamental problem is there's just too much data to process that quickly. So I guess in a sense, I've been working in big data for longer than I let on. But yeah, a lot of the problems there are basically how do we either simplify things or decide what not to display in order to make it possible to actually download all that content, and then for the GPU to actually be able to render it.
It's very interesting stuff. And you mentioned that through the work that you were doing with all those distributed systems, you landed with Kafka, and you're now working for Confluent, and you're the primary contributor to their Schema Registry project. So I'm wondering if you can just briefly talk a bit about what Confluent does and what was the motivating factor for building the Schema Registry and how that factored into the work that you were doing with Confluent.
Sure. So okay, so I guess to start with, Confluent is building a streaming platform around Apache Kafka. So Confluent was founded by three LinkedIn engineering team members that built Kafka at LinkedIn. And Schema Registry was actually one of our first products. It was included in the first release. And the reason, the sort of motivating factor for it is that the founder saw the same, like these set of problems play out at LinkedIn around scaling up the use of this sort of centralized streaming data infrastructure. There are some really powerful things you can get out of having a sort of, it's a distributed system, but sort of centrally managed system for storing all of your streaming data, your event data. But it gets complicated then when you have something that's shared by thousands of developers to be able to even do something as simple as keep track of, I have data in what Kafka calls topic. That's like a stream of data. And with thousands of developers, it's really hard to keep track of just even what is the format of the data or what does the data represent. And so the idea behind this service is that we can also sort of centralize the management, that metadata about the data, how like what the format of the data is, and documentation about what it represents. And this sort of enables three things. In a lot of ways, it seems like, or these days, a lot of the time we consider any sort of centralization a bad thing. But in this case, it's actually really powerful, and it allows you to do sort of three different things. The first is that you can actually validate compatibility of schemas as they change over time. So inevitably, you're going to see, my first version was missing a field that I want to store there. I want to be able to add it to the schema. What you want to make sure is that you do it in a compatible way, though, so that when you end up with both pieces of data at the same time having to be processed by the same application, it's still possible to do that processing against both of them without having to have 18 different variations of the same code to handle the different structures. So that compatibility ensures sort of data cleanliness and makes it a lot simpler to write applications that are able to support processing, both old data and new data. So that sort of ensures good quality data. The second thing that it allows you to do, and this is one of the reasons Kafka becomes really powerful when you put it as the sort of the center of your streaming data pipelines, is it allows you to then discover the format of the data. So I'm able to just go in and check with the schema registry what format, like what is the actual schema in the case of the schema registry. This is for Avro. What format is it in? And I don't have to really go talk to anybody in order to do that. So I'm able to just query for that information, get the schema back, and then potentially start using the data without ever having to coordinate with anybody. And so that actually turns out to be super powerful because it allows you to decouple teams from each other and removes a lot of sort of overhead that there is in processing and figuring out how to process data. And so you can imagine that there are things here where, for example, maybe you have one team that's writing a specific application. They want to log some events from it. So they're logging, for example, every time there's a user interaction, or page views is sort of a very easy accessible example. They may store that data into Kafka, store all of those events, but then frequently what we see is multiple downstream users also consuming that data, and they never have to coordinate in order to make use of that data. So it's a sort of very powerful way of making data as accessible to anyone in the company as possible. And sort of related to that is a third thing, which is that you no longer have to have this sort of central schema planning. And it turns out, I believe this happened at LinkedIn, and I know it happens elsewhere, where effectively if you don't have this tool in place and you don't have guarantees around compatibility and discoverability, almost universally what ends up happening is you end up with some team that's sort of the blessed team that's allowed to make changes to schemas, and you have to go through like reviews with them, and basically making any change or improvement becomes really painful and slow because it requires interaction with a bunch of other people. By having the schema registry in place, you have enough guarantees that you can feel a lot safer about sort of independently evolving the schemas. And even when you do have those teams that are effectively coupled because they're sharing the same data, they're still able to operate and evolve the schema, so that one team that was creating all the data is able to evolve the schema because they have these guarantees that they won't break anything downstream as long as they evolve it in a way that the schema registry guarantees is compatible. So it's sort of that set of things is sort of it's both the motivating factor for building it because the founder saw how this played out at LinkedIn, and it's also just sort of the set of benefits that you get from doing this allows you to scale up sort of your data management to a very large organization without really coupling any teams together, requiring any real overhead.
So does the schema registry enforce the schema at write time so that if somebody's trying to submit to a given Kafka topic that has a schema associated with it and the data isn't in an appropriate format, does it reject that data and cause a write error in order to ensure that the integrity of the topic is consistent with the schema that is associated with it at that particular state and time and version of the schema?
Yeah, that's exactly right. So sort of the first step is generally that when you initially publish some data to the topic, there are no schemas stored. So of course you're going to be able to write that schema. But the way this works in practice is you write with the Kafka producer, and your serializer basically goes and checks with the schema registry and tries to register the schema. If there's already a schema registered, it'll check whether it's compatible or not. And if it's not compatible, you'll get an exception back, an error code from the API, and then an exception back in your application. If it is compatible, you're actually allowed to just evolve the schema right there. And in terms of compatibility, we might want to get more into this later, but there are a couple different types of compatibility, and you can sort of configure which one you want. And so you have this sort of like toggle to say how strict you are in terms of your compatibility rules.
And is there any metadata that gets written into the record at the time of submitting to the topic that indicates what version of that particular schema ID is being used at the time of submission, so that if you are going back and reading through an entire topic from the beginning all the way through, you can determine what the schema was at the particular time that the data was written? Because I know that with Kafka, there are occasions where you might want to reprocess an entire event stream from the beginning.
Absolutely, yeah, and you need some sort of ID in the message in order to even just be able to decode it. This is sort of a quirk of the way that Avro works. Not all serialization formats work this way, but you have to have the schema that was used to write the data in order to be able to read it. That makes Avro very efficient, but comes with that cost of having to have the original schema. So what actually gets written is we have a format it's very simple. It's just a single magic byte. That's just so that we can ensure that we're actually looking at sort of the serialization format that we expect. And then it has an integer ID, which is the schema ID. Now, that doesn't actually tell you the specific version of the schema, or sorry, I should say, it uniquely identifies the schema so that you can go look it up and decode it. It doesn't actually tell you the version within that topic, because usually that's not actually needed, so you'd have to go through an extra step to look that up. But most applications don't need that version information. They just need to have the schema so that they can decode it.
And I know that with the Avro format, one of the strengths is the fact that it does allow you to co-locate the schema with the data as it's being written. So I'm wondering, what are the benefits over and above the built-in Avro capabilities for being able to track and manage schemas?
Sure. So you can embed. So the Avro format is actually there's two pieces to it. There's just the how do I serialize a single record into an array of bytes. And then there's the actual on-disk format. I think what you're referring to is actually the on-disk format, where the format of the file is essentially write the header, in the header of the file, just write the schema, and then have a series of records that are serialized with that schema. It may be a little bit more complicated than that, but that's the basic gist. So the problem with doing something like that in Kafka is that actually a lot of times schemas will end up being bigger than the data itself. And in Kafka, like you can imagine, you're writing a single record at a time, which means that you would have to dump the entire schema in with that record, and then write that one record, and then move on to the next record and do the same thing. So you're just putting a lot of redundant information in there. And so what having the schema ID and schema registry allows you to do is substitute the entire schema with a single integer. So that's not that big a deal to be repeating. Your data is probably large enough that that's not a high price to pay. And then still be able to go out and find that schema again, even though you don't have the entire copy of it. You just have a unique ID. So in a sense, it's actually kind of a requirement in order to use Avro with Kafka. If you want to be able to evolve the data over time, you need some record of what schema was used to encode it, but you're not going to want to dump the entire schema into every message, so you need some other mechanism.
Yeah, I can definitely see how having the registry is a good way to sort of decouple the data and reduce the overall storage overhead associated with keeping all of that information. And I'm wondering how you settled on Avro as the serialization format and the schema format to support, and what are some of the other options that you considered, thinking in terms of things like Parquet for the actual on-disk format, or things like JSON schema for being able to define the actual schema itself?
Sure. So we talked a lot about this during the initial sort of product design phase. So at LinkedIn, Avro made a lot of sense, and they adopted it because a lot of the systems that they were working with are sort of big data systems. And in the Hadoop ecosystem, Avro is fairly pervasive. So the sort of trade-off is that outside the Avro world, if you're sort of like a regular application developer, it's not nearly well as known. It has support across a variety of languages, but not maybe all of the languages that you would want to use it with. So there's definitely a trade-off here. The other thing that I would say is popularly requested is JSON schema. It's actually kind of funny because it's people applying schemas to a schemaless, like an intentionally schemaless format. So it feels a little backwards, but it's a good thing that they want that support. In terms of what we built what we thought would best address the needs of our users, which many of them are coming from sort of a big data background, so they may are either already familiar with Avro or it fits in well with the rest of their ecosystem. That said, we're actually more than open to adding other support. It's just a tough thing to find on a with a long list of product features that people are looking for. Hard thing to find time for. I've also heard requests for other serialization formats as well. For example, protocol buffers, thrift. There are a couple of other more fringe ones that we occasionally get questions about. We're definitely open to adding more support. I'd like to see the JSON schema support. To be honest, one of the other factors here is that Avro the spec has very well-defined compatibility rules and sort of built-in understanding of how to project between different versions of schemas. And the tooling is already there as well. So this is built into the Avro library. This isn't something that the Schema Registry that we had to build for the Schema Registry itself. And so you don't have that in things like JSON schema, and JSON schema is actually a fairly complicated spec. It's actually more complicated than Avro because it applies some other, you can apply other constraints on there, say things like this field has to be between this range of values. And there's a bunch of complicated stuff like that would make actually doing these compatibility checks a lot more complicated than it is in Avro. So I think we could extend support to it, but couldn't say a particular time frame because it's a pretty substantial project.
And in terms of the compatibility that you've mentioned, what are the sort of dimensions along which you can evolve a given schema in order to ensure that messages that were submitted at an earlier time can be coerced into the new schema format?
So actually, the first thing I'd say here is I would highly encourage people who are interested to go read the Avro spec. It's a very straightforward, relatively simple, and well-written sort of design doc and specification, and it includes information about how this works. It's a very simple list of how you take two schemas and resolve them. In terms of operations that you can do, it's mostly the sort of obvious things that you would think of. So I'm missing a field and I want to add one. That would be a backwards compatible change. And here we're going to get into sort of the different types of compatibility. But what backwards compatibility means is that with a newer version of the schema, I'm still able to read old data, which you can imagine for backwards compatibility is going to be a popular option because it allows you to read all historical data, even on the most recent version of your application. And so adding a field is backwards compatible because if I include a default value, then I should say that adding a field with a default value is backwards compatible. Then when I load some data from an old schema, even though that field is not there, we have a default value that we can fill in. So we still have a path to sort of getting it into the newer format. There are some other things like actually removing a field is also going to be backwards compatible because when I read an older version, I just ignore that field and that's fine. It is possible to rename fields in a backwards compatible way, but you can't do things like changing default values. You can do things, Avro is actually kind of unusual in that it supports a union type. Union types, if you add sort of another type to that union, where by union type I mean you can say this field can be either an integer or a string. If you then say it can be an integer, a string, or a long, that's also a safe operation because you're just adding to the set of types that you're allowed to decode there. So I think that's there's probably some more of them, and there are probably some more extending enum types in certain ways can be a safe operation as well. But the vast majority of the time, what people care about is just adding and removing fields.
And for the schema registry itself, right now it's fairly I don't necessarily want to say tightly coupled, but it's very closely associated with Kafka as the storage backend for being able to propagate those schemas and, associate the schemas with the data being written. Are there any other storage backends that you've considered expanding support to with the Schema Registry? Or for somebody who isn't using Kafka, are there alternative tools or technologies that people can use for being able to achieve similar outcomes?
Sure. So I guess that there are two aspects to being tied to Kafka. The first is actually the storage layer. So for those who aren't familiar, the way that the Schema Registry actually works is that it allocates a single partition topic, and that's where we store all of the schemas. Basically, each schema is just a record in that topic. That makes it super simple because if you have Kafka, then getting up and running with the Schema Registry is just one basically stateless app that you have to deploy, which people are used to doing. That's easy. So in terms of the storage layer, that is actually already abstracted out. In fact, there's a second implementation called in-memory store in addition to the Kafka store implementation, which, as you can imagine, just holds all of the data in memory. This is useful both for testing and actually we effectively use it as a cache inside the Schema Registry. That store interface, though, while we haven't exposed any configuration in order to make it pluggable, basically all the support you need is there. And the API surface area is really small. It kind of amounts to a hash map, because that's effectively what the Schema Registry boils down to. It's just a map of IDs to and versions to the actual schemas themselves. So that's the storage side. The thing I do want to, we basically just need to add a config in order to make it really pluggable. I've very, very occasionally heard requests for can we just use MySQL or something, because we already have a MySQL database that would be handy to use for this. We can just reuse that piece of infrastructure, not have to deploy Kafka itself. That would be sort of a reasonable thing to do. And in fact, the entire design of the Schema Registry was intended to support using it with other systems in addition to using it with Kafka. Obviously, the sort of storage is an implementation detail, not something sort of fundamental that you can only use this with Kafka. So and in fact, you could use it with, for example, basically any legacy messaging system. If you needed to still pass some data through there, it would be reasonable to use the exact same sort of format and APIs that we use for Kafka. So that's one aspect of it, which is storage. The second aspect is actually the rest of the implementation of the distributed version of Schema Registry. And we're actually, that would be a harder thing to replace in terms of the implementation. So while I think you could plug in a different storage backend, you would still currently need Zookeeper or Kafka for coordination. And the reason for this is that the way it's designed is to make it as easy as possible for the client. And the way that we do that is we have a single master architecture where one of the Schema Registry nodes is elected the leader. And in order to do that, we need some sort of coordination system. So it would be a much bigger change to replace that. So right now, it probably still best works if you're going to have Kafka in your environment anyway, but it is definitely feasible that you could do this some other way. So I think you also asked about sort of other options in terms of if you don't have Kafka in your environment. So I would actually say still use Schema Registry. You kind of there are alternatives available in the sense that you can use other approaches. For example, a common alternative solution here is actually just check everything into Git or whatever your version control system is. It doesn't give you the exact same benefits, but it does give you probably the most important one, which is some way to validate the compatibility with old versions. And actually, because of this, one of the best ways to do it, if you're going to do it in Git, is to make sure that you actually save a copy in the current source tree of all the old data and have a tool that goes through and actually validates during a pre-commit hook or something, validates that any new versions are compatible with all the old ones in the way that you want them. It does give you also potentially a sort of central discoverable place for storing those formats. So if you need to find out what the format of some data is, you're able to go do that easily. If you're doing this in Git and you're in a many repo world, I would highly recommend putting all of those into a single separate repo that everybody depends on. Or if you're in a single repo world, then you want to put them all in one sort of central location in terms of directory structure, just so that in terms of coordination and having to bug other people to find out the format of data, it's not like you're gripping through the entire source tree or anything. You know exactly where you have to go for it. Now, I would say, however, that this is sort of a suboptimal solution. It's not that great. It actually is pretty close to what you see in some other systems. So, for example, it's pretty common to have database schemas and migration scripts checked into your repository, and frequently for every previous version. And that's basically trying to accomplish the same thing in terms of sort of compatibility and, in that case, repeatability of doing deployments, and guaranteeing that if you do sort of change the schema, you have a way to convert existing data, which is similar to the ability to convert data on the fly when your application is reading it from an old format to a new format. And yeah, I mean, other than that, I would say basically you're down to using the Avro compatibility checks that the Avro library provides and doing your own validation somewhere in your pipeline. I think there's at least one other like sort of open source schema registry that I'm aware of, but it comes with effectively the same operational overhead, so you're still going to use it. I guess the other thing I would say is like don't overestimate how difficult it would be to run these three things. If you're talking about a very lightweight solution, you can probably run, and you're not too worried about like sort of the HA, and you have an approach to back things up, then you could potentially just deploy a Zookeeper and a Kafka on the same node, and then just deploy Schema Registry against that. So it's not like, minimum of 6 nodes just to run Schema Registry if that's the only thing you're currently using Kafka for. So that's definitely an option. It's, we don't normally recommend that people run Zookeeper and Kafka on the same node. And obviously, generally with Kafka, you want to get all of the nice HA replication features. But for that particular use case, if it's just to run Schema Registry, you might be able to get away with a very lightweight deployment, such that it's not that big a deal. And if it's that lightweight, generally the maintenance cost is not very high. There's not a lot of things that can go wrong when your traffic is registering a schema every once in a while.
And one thing that I briefly want to mention for the listeners that I'm not sure if we stated explicitly yet is that the schema registry itself is open source and publicly available for anybody to download and use if they did want to add some of the support for alternative storage mechanisms or any other particular modifications that would potentially be useful.
Yeah, that's right. We Confluent has a wide variety of open source software. This is infrastructure stuff, so we definitely know that you want to not get locked into a completely proprietary solution when this is the thing holding all of your data.
And what are some of the biggest challenges that you faced while designing and building the schema registry?
A few different things. So the first one is something that we already discussed, which is just deciding what format to use. Because Avro has those compatibility checks well designed and built in, that was a pretty big one. Another item, actually, so I since we were just talking about the storage backend a little bit ago, the storage backend actually wasn't a tough decision. That's an example of one where it was easy. One of our goals with the way we build services is to aim for services that have as few moving parts as possible. And since we were sort of working under the assumption you're building around Kafka anyway, given obviously what our company does, we're not requiring a sort of additional storage service is kind of a no-brainer. So then other challenges, though, would be the high availability and multi-DC design. And there are a couple of different ways that we could have gone here. For example, do you have one global schema registry that's like completely actually global and spans DCs across the entire globe? Or do you have multiple, and then somehow as you're moving data across DCs, you're able to sort of rectify the two or convert between the format or the schema IDs for different data centers. So our conclusion was that one global schema registry would be much simpler to reason about. You don't have to think about where your data was produced just to figure out how to decode it. This is actually particularly important because usually when you're getting into multi-DC solutions, at some point you're aggregating the data into a single DC in order to do sort of additional analysis that requires the global data set. And that would get a lot messier if we had gone with a sort of multiple separate deployments approach. You obviously can still deploy it that way, but we designed around the fact that you would want to deploy a global schema registry. One of the important results of designing for the global schema registry mode is that we made sure that you could serve reads even if you get sort of disconnected from the source of truth. And so what I mean by that is that the schema registries across all the data centers will load up the entire data set And the assumption is that it basically fits in memory so that we can hold on to it in memory as and cached, which isn't crazy because the schemas are not going to, like, your total schema data set is not going to be very large. And then even if those nodes get disconnected from the sort of central Kafka cluster that stores the data that they're loading the data from, they're still able to serve requests to fetch schemas by ID. So you'll still be able to consume data even if that data center gets disconnected. The thing you won't be able to do is register new schemas, but this is sort of a reasonable trade-off because, I mean, you can imagine if you're having some sort of network outage between data centers, probably your biggest problem is not being able to deploy an updated version of your code that includes a change to the format of data. So more than likely, what you would just have to do is hold off on deploying any changes. But in truth, the likelihood of having those two things happen at the same time is pretty low anyway. And it's not sort of, in terms of business terms, not really a significant problem if you have a decent deployment setup. Yeah, so that's the sort of the high availability and multi-DC story. And then more recently, one of the things that we've basically, it's not really a design decision, but we were originally completely reliant on having access to ZK. And that's actually how different Schema Registry instances coordinated to elect that one leader that's allowed to actually write new schemas. So from a simplicity perspective, that's actually something that we weren't necessarily super happy about because, as I said, we're trying to have sort of as few moving parts, but also as few things that you have to understand and configure the like connections between. And so having ZK there wasn't necessarily great, but at the time it was sort of a necessary evil. We actually added support now for, and this will be coming out in the next release, added support for using Kafka's group protocol in order to coordinate and elect a leader. And this is actually a functionality that I think a lot of people aren't aware we generalized in Kafka. It used to be that the consumer group functionality could only work for consumer groups. It was sort of tied to this idea of subscribing to topics. We actually abstracted out one layer of that so you can separate coordinating groups from then what they are doing on top of like being in that group. And so we actually did that when I was writing Kafka Connect, because that's how Kafka Connect workers coordinate with each other. But then we reuse that functionality again in Schema Registry so that you can basically now configure it so you just point it to Kafka, and the coordination just sort of all works for free. And so configuration actually got a lot simpler now, and the configuration and setup. So I think those are sort of the high ones. The sort of format was the biggest sort of, I guess, core decision in terms of what we support first and what we support first, and then what we generally support or could support long term. And then the sort of high availability and multi-DC, they're both that design and the sort of trade-offs you make in terms of global availability and how that sort of failover works. Actually, sorry, I should step back. I did forget one thing about the multi-DC thing. The trade-off with the multi-DC approach, one of the trade-offs with the global approach, is that it does actually make a failure event a little bit harder to work with. There's a bit of a manual process here where in order to, when you have a global cluster, basically, if you want to ensure that the leader is always in a specific data center, you have to configure the other data centers to effectively be not master eligible. And this is commonly used if you have a multi-DC setup where you actually want to be able to fail over all of your systems dynamically in order to handle some outage. But the process for doing that is a little bit manual. And part of the reason for that is because going with the sort of global cross-DC approach makes it a little bit more complicated. You have to actually reconfigure the nodes in the backup cluster in order to make them eligible to be leaders again, in order to serve writes again. So there's a little bit of a trade-off there design-wise.
And is there any particular tipping point, in your opinion, in terms of the scale or complexity of a system or organization, at which point it makes sense to invest in the shared schema registry? And conversely, is there, sort of size of a company where if they're smaller than a given, size and complexity of system and number of people, that having the schema registry doesn't really provide any large benefits as compared to the effort of deploying and maintaining it?
So I guess there are a couple of ways to approach this question. So one is whether you have schemas at all. And if you don't have schemas, you're basically just continuously building up tech debt, and honestly, it's just very risky. So I would discourage ever not having schemas in the first place. And then it's actually pretty painful because then when you decide you do need schemas, you got to transition from a schemaless format to a format with schemas. So that's a mess. So I guess, you know, the point about then complexity, though, kind of ties back to what I said earlier, where if you want to scale down sort of the Kafka deployment, you can do that in a way that actually makes Schema Registry pretty cheap and easy to maintain anyway. But let's say that you aren't even comfortable pulling up like the 2 or 3 nodes, and that's just still too much. I think the primary alternative, honestly, is just using version control to act as your central repository, and that can work. It'll work for small teams. I think the major drawback here, and this ties to sort of it being worth thinking up front about your data formats. The drawback is that if you're not careful about building in some sort of versioning and ability to migrate to an updated format eventually, it can be very difficult to then transition over to using something like the schema registry as you grow. And that actually ties to, I mentioned earlier with the format of the data, one of the reasons we have the magic byte there is not only to validate that we're looking at the format of data that we expect, but also so that we can change that magic byte to something else eventually if we need to, in order to update the format with some new features. For schema registry, that's kind of unlikely, but it's sort of a key thing when designing these serialization formats or protocols, anything like that, to build in that versioning from the get-go. And so if you do this, if you do decide to use sort of a central repository, the other thing that I would recommend is making sure you have that version and basically just use the same format that we do, which is documented in the schema registry docs. That makes it at least possible to migrate over eventually. Let's see. So, and then in terms of size, the thing is, I don't want to put like a concrete number because it obviously depends on the organization and like, for example, your familiarity with Avro and that ecosystem, but even for a small, like say 5 to 10 person organization, the like discoverability that you get from having that centralization can actually be a pretty significant win just in terms of reducing coordination. So basically, once you're past the point where everybody looks at all the code, it's probably time to make sure you have some organization at least set up, even if that does end up being put it someplace central in version control and make sure it's all sort of shared library of those schemas. That helps actually also in terms of not just being able to discover the format of data, but it encourages reuse. So if I have to go into that directory and see that, oh, somebody already added a serial, like a schema for this type of data, and I just wasn't aware of it because I hadn't started on it yet, it gives you the opportunity to then reuse that and sort of standardize and end up with less schemas overall, or fewer schemas overall, even if you're, pretty small, 5, 10, 15 people. So I'd encourage, in terms of tipping point of central repository, I would say it's very, very low before you start getting value out of it. In terms of schema registry itself, maybe it's a little bit higher if you're not super comfortable running Zookeeper, Kafka, and then also adding on the schema registry.
And also having that canonical source of what the different schemas and data formats are across your applications and organization helps with onboarding for any company that is small and is looking to grow in any way, shape, or form, because then somebody who's new to the application can come in and just very quickly see these are the types of data that we're dealing with, and these are some of the places that it might be used.
Exactly. And so like even let's say you're not even using it with Kafka, let's say you're using it, I mean, this is probably less likely, although you could do it. Let's say, like, if you're using it with like HDFS or something like that, you can have an intern come in and very easily figure out how to get data and what the format of the data is. And I think of this in terms of interns because I think it's one of those examples where it's sort of like we might give them a project that we think is a good idea to do, but we haven't found time to do it. And it's like leveraging this data set that we have from some existing application. That's sort of a classic example of rather than having them have to go to that other team who maybe isn't even the team, managing the intern and coordinate with them to figure out all of that stuff. They can just go, their manager can just direct them to the central data and say, or to the central sort of registry. And then they just have to figure out, okay, well, there's this topic and it has this or directory, whatever, and it has these schemas in it. And, with Avro schemas in particular, they can and should include documentation for all of the fields and everything. So it's basically a fully documented index of all of the data that's available in your company and makes it super easy to get up and running.
And what are some of the upcoming features or enhancements that you have in mind for the project?
Sure. So I mentioned one of them already, which is making it so that you don't actually have to use Zookeeper for coordination between the different instances when you're running in HA mode. Let's see. So other ones would be more security features. So this is actually, not super important when you're first getting started with Schema Registry, but if you're really trying to scale it up in organization, having access to or having control over sort of access control lists. Basically, if I want to restrict schema registration to only happen for my CI/CD pipeline. Or you can even, I think this is less common, but you could even lock down read access if you have some sort of sensitive data in some of your schemas. So those are things that are definitely coming up soon. Another thing that would be on my roadmap would be the support we talked about earlier for other serialization formats. I personally would really like to see protobufs, but I think JSON schema is probably more likely in terms of popularity. But yeah, protobufs, thrift, XML, all of those could potentially be included. And then actually outside the service itself, we kind of lump these together frequently, but there's sort of the service itself, and then there are clients to that API and sort of serializers built around those clients. So I'd like to see better or improved language support. We currently have support for Java, C and C++, and Python. We would like to fill out support for other languages. I think .NET would be a popular one, potentially Go. There are probably a few others there as well. These, obviously, from my perspective, I'm thinking of it in terms of clients that Kafka clients that we also develop. So those are the languages we tend to be a little bit more focused on. I think those are probably the major features and the major directions. To be honest, Schema Registry in a lot of ways is like actually a super simple project because the core of it really is just registering and reading schemas. It's only a few different APIs. So there's not actually like a huge amount of direction it can go. It's super important for your data sanity, but the service itself actually doesn't have too much going on there. So. And I guess actually I should also mention, since you brought up the storage backend, it's something I'd like to see. I don't know that it makes sense from a Confluent product perspective, but it's definitely something that, if we had some contribution or something from open source contribution, we'd be more than happy to get that in there. Are
there any other aspects of the project or related topics that you think we should talk about before we close out the show?
I think we hit the major ones. I guess the only other thing I might bring up is, this actually, obviously this is part of the bigger Kafka ecosystem. We tend to, when we're talking about Schema Registry, get sort of a little bit stuck in the sort of low-level details, like, oh, this is what the serialization format is, and this is how a producer and consumer interacts. We're actually trying to move sort of the level of abstraction that people are operating at a little bit higher. And I guess one thing we haven't really talked about is how Schema Registry helps you in terms of your sort of larger data pipeline. I talked about it in the sense that how it helps you scale an organization and scale their development. But there's also a matter of sort of how the different pieces ultimately tie together in terms of, I guess I tend to think of it in terms of ETL pipelines currently, because that's how I in my mind, how I break down the sort of ways that you use Kafka. So, this ends up integrating up into Kafka Connect, which is sort of the Kafka import-export framework, or I refer to it as import-export framework. It's basically connecting to other data storage systems or other systems generally. So it allows you to get data into Kafka or out of Kafka. And obviously an important consideration there is the actual serialization format and keeping track of schemas, especially in systems where the schema may not be fixed. So a good example of this is if you're loading data from a database into Kafka. So you basically want to see every change as an event. Like literally every row that changes comes in as a separate event into Kafka. And so that is effectively a dynamic schema because the schema is defined somewhere else and it may be updated over time. There's sort of effectively automatic integration via the serialization layer that we have in Connect. But one of the nice things there is that it also means that Schema Registry actually, in a sense, ends up documenting other system schemas for you when they're not doing it for you. So instead of having to go to your database to get the schema, you might actually just look at some of the data coming out of, look at the schemas registered in the schema registry for that sort of import process. And sort of same thing with taking data from Kafka into other data systems. And so I think the thing that sometimes gets lost in the bigger picture is that it's actually documenting your entire pipeline even beyond sort of what you hold in Kafka itself, which can actually be very powerful because it gives you a single place, even if not everything is stored in Kafka. If it's passing through Kafka at some point, you get sort of automatic documentation of your entire data pipelines, data formats, even when they end up, not necessarily the thing that you might be going to look up with a schema for, maybe like in a database, but you can still do it through the schema registry. And then, of course, it ties together with the sort of transformations and all of that. So it integrates well with sort of seamlessly with all of your like stream processing applications, for example. So, and I guess maybe the one last thing is, I think it's really important to think about the sort of upfront, think about data design, serialization, how you deal with compatibility, how you're going to evolve schemas over time. And it sounds like it can be very daunting, but in practice, actually, a lot of what deploying the schema registry means is run it and then use the right serializer, and then basically don't think about it again until you see something like incompatible failing. So it sets you up to be in a good place, but it doesn't necessarily have to be a huge investment up front.
All right. Well, this is a very fascinating topic and a very interesting tool and approach to a widespread problem that some people may not realize that they have yet. So for anybody who wants to follow the work that you're up to and keep in touch, I'll have you add your preferred contact info to the show notes.
Sure.
And as a parting question to give the listener something to think about, from your perspective, what is the biggest gap in the tooling or technology that's available for practitioners of data management today?
First of all, I think it's a little bit hard to pin it down to one specific gap because data management actually covers sort of a wide variety of technologies, sort of tools, and I guess types of systems as well. So, right, the sort of big data space, I think a lot of tooling has at least been filled out recently. So obviously, and this is clearly biased given the company I work for, but our biggest gaps tend to be around tooling for real-time systems. And in particular, I think one of the big gaps is in basically visibility into these systems, but not visibility into a particular system so much as an end-to-end visibility and understanding. We build a lot of tools that, and this is not surprising because we're still sort of early in the stream processing space, but we build a lot of tools that solve one sort of very narrow specific problem. And while I think that's the right place to start, what you end up with is a lot of different pieces, a lot of different applications. In a large organization, you'll also end up with just a lot of applications deployed in parallel and possibly depending on each other in ways that are actually pretty hard to understand. Basically, you have nobody in the company who can tell you if I change this thing, what is the impact going to be? And so I think the sort of biggest gap, this is sort of open-ended and it's not a specific tool per se that's missing, but being able to understand all of those dependencies and how things interact, I think is probably the biggest gap because it's the sort of biggest risk for making any change. I think Schema Registry is one part of addressing that problem, but Schema Registry is totally focused on sort of serialization, format, and compatibility of data, whereas I think there's a sort of bigger tooling problem where even being able to understand how data flows through all of those systems is really challenging. I think there are probably some, I guess, initial stabs or very company-specific solutions to that. I think distributed tracing systems are an example of this, where they actually do allow you to get a little bit better information about how, say, a particular request flows through various systems. But I think we're still sort of taking the initial baby steps with tooling like that, and there's probably a lot more to do there that would help people understand. I mean, it sounds a little bit crazy, but to help people understand what they've built, because it's easy to get lost in the complexity.
All right. Well, thank you for your time and the work that you've been doing on the Schema Registry. It's definitely a very interesting project, and I'm curious to see how it evolves and grows, particularly if and when you have time for adding support for additional schema mechanisms. So thank you again for taking the time out of your day, and I hope you enjoy the rest of your evening.
Thanks. It was a pleasure.